Hello everyone, and today it's the 23rd of December, and we are going to test AI models on the challenges of day 20, 21, 22, and 23. But we are going to do this in the separate streams, so keep going on the channel or go into my Telegram channel, which I'm going to post the link in the comments. So that you can keep watching all the streams. What we are going to do, we are going to test different models. Currently, I have a list of 2 Claude models: 3.5 Haiku, Sonnet, Gemini 1206, GPT-4o Mini, GPT-4o, O1, O1 Mini, and we also are going to test DeepSeek as well, a Chinese model. We could try at some point testing Gemini 2.0 Flash Thinking, which is in an experimental mode. Seems to be on par with Gemini 1206. Well, but we'll see that. So yeah, we firstly are going to read all the description, trying to understand what the task is about, and then I'll go into O1 Pro. Probably I'll try to get this, or O1, try to get solving the first part, because there are 2 parts of the tasks. I'm going to solve the first part, because the second part is opening after you solve the first. So we're going to prompt briefly O1, and then we'll prompt all our models with both tasks at the same time. So both descriptions, and the model will try to solve both tasks at the same time, and that's how we are going to measure their performance. Okay, so let's start.
The historians are quite pixelated again. This time, a massive black building looms over you. You're right outside the CPU. While the historians get to work, a nearby program sees that you're idle and challenges you to a race. Apparently, you've arrived just in time for the frequently held race condition festival. The race takes place on a particularly long and twisting code path. Programs compete to see who can finish in the fewest picoseconds. The winner even gets their very own mutex.
They hand you a map of racetrack, your puzzle input. So here ours map. So we have a starting point, the end. Those are the walls, and yeah. What should we do? Again, finding some path.
When a program runs through the racetrack, it starts at the start position. Then it is allowed to move up, down, left, or right. Each such move takes 1 picosecond. The goal is to reach the end position as quickly as possible. In this example racetrack, the fastest time is 84 picoseconds. Because there is only a single path from the start to the end and the programs all go the same speed, the races used to be pretty boring. To make things more interesting, they introduced a new rule to the races. Programs are allowed to cheat.
Okay. So again, this is a task about finding a path through the maze, but like the shortest path. But we'll see what's the cheat thing.
The rules for cheating are very strict. Exactly once during a race, a program may disable collision for up to 2 picoseconds. This allows the program to pass through walls as if they were regular track. At the end of the cheat, the program must be back on normal track again, otherwise it will receive a segmentation fault and get disqualified. So a program could complete the course in 72 picoseconds, saving 12 picoseconds by cheating for the 2 moves marked 1 and 2.
It reminds me of a quantum tunneling. So that there is a probability that a quantum particle can go through through some like another particle, because there is a probability of finding a particle in some region, and the region, like, it can be, you can consider 3 points as a probability where you can find this robot or whatever is moving, and therefore it cannot usually like go into the like the probability is traveling through the wall is very small, but here we like we are allowed to explore all of the possible moves through the walls, but we are going to pay for that, like for that move, as one additional picosecond. And what else? But and we also need to go back to the original, like to the track, to the normal path. So that means that you cannot go through 3 walls at the same time, or in other words, you can the probability of finding the path in this like moving through 3 number of walls is really small, that you cannot do that, but you can do that with 1 wall only. So okay, let's see.
Or a program could complete the course in 64 picoseconds, saving 20 picoseconds, by cheating for the 2 moves marked 1 and 2.
Okay, so there are 2 walls apparently. What are those? 1 and 2. What does it mean? Okay, by cheating for 2 moves. But here are... what? We don't have a wall here. Not sure I understood how they get 12 here. Okay, this cheat has saved 38 picoseconds. 1 and 2. Okay, let's see. We have okay, so there are 2 walls over there. Oh no, that's not it. Okay, it's this point. So 2, 1. Okay. Why don't they have 2 on the wall, but on the track? Okay, in any case, so it's like if you found a wall and you are going to go through it, you add an additional picosecond. Oh. Okay. I think it doesn't mind if they don't mind where the positions of those numbers, so it doesn't matter. We can place 2 here, 1 here. Okay, this saves 46 picoseconds over there, and we'll see. So end is here, and okay. So if we go just through this wall. Okay, what's next?
Each cheat has a distinct start position, the position where the cheat is activated just before the first move that is allowed to go through walls, and end position. Cheats are uniquely identified by their start position and end position. In this example, the total number of cheats, grouped by the amount of time they save, are as follows.
So do we need to have an XY position or not? 14 cheats that save 2 picoseconds. 14 cheats that save 4 picoseconds. 2 cheats that save 6 picoseconds. Okay. Oh no, we don't need to have a position of the wall that we're going through, but we need to have probably what you aren't sure about positions will be like. So give yourself as many options as possible. You'll need a list of the best cheats. You'll need a list of the best cheats. How many cheats would you save? At least 100 picosecond. So what's the answer? Could be like how many cheats? So the number of them. Okay, so there are 14 cheats. Okay, no problem. Again, we need to find all the paths, and then we need to find all possible like cheats, like going through the walls, and then build other paths, or we like yeah. Okay, so let's go and just go straight ahead to the ChatGPT and prompt 01. So I'm copying this description. I also need to copy the template. We have read input, part 1, part 2, main that runs this. Okay. And also I'll be copying cursor rules. And I'll be saying that, sorry, I will show you the screen in a moment. Solve the first part of the task using the template. Also, we need to find our puzzle input, which is a maze. So not today, we are solving day 20. Let's open 01. And yeah, okay, so solve the first part of the task using the template. Yeah, I think with the dot input txt. Okay, here's the here's the ChatGPT. I'm using 01, not 01 Pro, so it won't take it too long to solve. So because 01 Pro will like spend 2 or 3 minutes, and here we're just solving it in 14 seconds. We can use though the 01 Pro for solving both tasks, both parts. So what's the solution? Find normal the shortest distance with normal moving, no cheating. Then what? So basic BFS setup, directions, go within Q. If we cannot reach E, should happen, okay. But what's about cheating? Okay, below there's an example which simply finds the shortest Y. No, the first part is about finding the number of paths with cheating. Read again. What's the point and what should be the output? I will probably need to modify my my original prompt so that other models won't be confused with this as well. Okay. So high-level solution outline. This is interesting. Parse the grid. Locate start and end. Compute baseline distance from start to end using using a normal BFS that avoids walls. And then pre-compute distances. Okay. Enumerate possible cheats. A cheat is defined by a pair of track cells, where T is cheat start cell, where you activate the cheat. U is cheat cell end cell, where you finish the cheat. You must be able to reach from T from S. You must be able to reach E from U in normal mode. The time from T to U using the cheat is exactly number of steps, 1 or 2. Need to move ignoring the walls means U must be reachable. Okay. Calculate the saving, count how many pairs. Okay. So BFS normal, then cheat distance from 1 or 2. Returns dict mapping, main steps, ignoring walls if it can be done. Okay, so here's another one. If we are on a valid track cell, store the cost. We can end cheat if there is a dot or S or E. Okay, distance so far less than 2. We can move through. We can move further ignoring walls. Why? Okay, count how many distinct cheats. Start position yield. How many cheats yield saving more than 100? Okay. So far looks like a correct solution, but we'll see. So Python 01. Okay, so we have a number 1429. Let's see if that's correct. And yeah, this is a correct one. Perfect. So 01 have solved the first part of the task. And now let's read the part 2, and then we are going to prompt all our models.
The programs seem perplexed by your list of cheats. Apparently, the 2 picosecond cheating rule was deprecated several milliseconds ago. The latest version of the cheating rule permits a single cheat that instead lasts at most 20 picoseconds. Now, in addition to all the cheats that were possible in just 2 picoseconds, many more cheats are possible. This 6 picosecond cheat saves 76 picoseconds.
Okay. So we have we could have a single cheat that instead lasts at most 20 picoseconds. And here they're showing not the 20 but 6. So it's like we can go through 6 walls, or in our case 20 walls. Okay, this is more complicated because we have a larger maze. There could be 20 walls stacked one on another. Okay, so because this cheat has the same start and end positions and the one above, it's the same cheat even though the path taken during this cheat is different. Okay, this is considered as the same cheat for some reason. Okay, so if we go through the walls, doesn't matter how you go, it doesn't matter where you end up after you are going from them, like after you are finished going through the walls. Okay.
Cheats don't need to use all 20 picoseconds. Cheats can last any amount of time up to and including 20 picoseconds, but can still only end when the program is on normal track. Any cheat time not used is lost. It can't be saved for another cheat later. You'll still need a list of the best cheats, but now there are even more to choose between. Here are the quantities of cheats in this example that save 50 picoseconds or more.
Okay. There are definitely a lot more paths. Find the best cheats using the updated cheating rules. Okay. So let's start with O1 Pro, probably. I am not allowed. 1 second. So I'm prompting the same thing, except for that. Let's stop. Yeah, I need to do this in another way. So I'm copying the whole task containing 2 parts. Then I am copying our other part of prompt. I need to remove the part that contains the answer for the first part, so the model won't be confused that we have already solved it. And I'll ask solve the tasks, both parts, using the template with the input. Yeah, what do I need to do anything else? I think from the context it should be like clear that the model should find this like number of path with cheats. I hope it won't be confused now. So yeah, here's our O1 Pro. Started thinking about this this task, and then we are going to prompt the same way all our other models. So let's start from let's do with O1 Mini, I think. Let's select O1 Mini. Oh, we have O1 here as well. I'll need to pay for that additionally to the subscription costs. So O1 Mini selected, model O1 Mini selected, normal mode, and yeah, let's go. Okay. So O1 Pro is thinking, O1 Mini is thinking. Let's prompt Claude. Let's start from Haiku 3.5 Haiku. And it's thinking. Then I'll create another window for Sonnet. Then Sonnet is giving us the code. We could, in principle, could run in parallel the GPTs, but we have we have other models to test, like DeepSeek. Let's paste it and enable DeepThink. And also let's test Gemini. Gemini experimental 1206 and run. Okay, it didn't think. It started to output the code straight away. So let's just for this experiment delete and try thinking model. Okay, it's started thinking. It started planning. That's good. That's definitely better. Data structures, algorithm outline, important considerations. Started writing some code, but it still is a thinking process. I wonder what happens next. Okay. Oh, it just output the same code. Let's try Gemini with this code first, and then just for the sake of experiment, and then I'll switch back to 1206, because apparently it is a larger and more smart model. Do we have an answer from? Yeah, we have an answer from O1 Pro as well. What? Below is a minimal working example solution. Again, it's not working at all. I'm so disappointed with the O1 and O1 Pro when it does this thing. Why would you do that? Why would you think for 2 minutes to give me output of this, I don't know how to call it, solve task, both parts using provide a full working solution that will, I know what to say, like a full working solution, full code. Okay, let's go. We have something from O1 Mini. Part 2 is solved, apparently. Part 1 as well. And seems like there's not a lot of code there. Let's try O1 Mini. Yeah, it didn't solve it at all. Okay. Let's see. Let's go through the solution. While Q cheated, cheat time, cheated, where's cheated thing? Cheated and time, cheated and visited, cheated, Q pop left, Q, which is what? Row column time cheated. But be fast to find all possible cheats. Let's save at least. Q start. I don't think it understands what the cheat is. So again, it's O1 Mini. It seems like it didn't understand the task at all. Yeah, I'll be filling out the results. We have not a lot of time. So okay, so O1 Mini, part 1, part 2, failed. So far, yeah, we'll try O1 whenever it's finished. Let's go with Claude, which is this Haiku. Okay, so let's copy Haiku solution to the Haiku file. Let's see whether it's solved at least one. Okay, it's firstly we can see that it takes some time to solve even the first one. If if it, yeah, even the first one. It starts from solving the first, then it goes to solving the second, and seems like it already is doing something wrong. Okay, in any case, are we closing the haiku? For anyway, yeah, I closed it as anyway. Let's open the code, which is not opening for some reason. Why? Okay, so here's it. Here it is. We have again, we are using heap queue. Find cheating paths. Yeah, seems like it understands now what's the cheating path. Let's see if Sonnet at least did something. I think I won't be giving Cloud 3.5 Haiku any points for that, because it probably just stuck in a loop. Let's see if Sonnet gives us something. Yeah, again, we'll need to check if it solves. Yeah, it solves them separately. So again, it seems like it's stuck in a loop because it doesn't return anything even for the first part. So okay, so failed for the haiku. Sonnet. Let's see, but I think it will fail. Now, while we're waiting, we are just going to copy and create another composer. We're going to use GPT-4o Mini. I have no faith in this model, but yeah, let's just for the sake of the experiment try. And yeah, O1 Pro is still thinking. Sonnet gave us probably incorrect answer. We have something from Gemini. And also, where's the DeepSeek? Oh, okay, it's here. Okay, we have something from GPT. Oh, wow, allow cheat, true. Yeah, it seems like. Okay, so where's the? Okay, so it just removed read input, and also I don't see like. Okay, so just BFS function. What does the allow cheat do? Allow cheat, where's that? Okay, so okay, if grid is this and allow cheat and not use cheat is probably yeah, it's definitely incorrect one, because even for the second part it should be using like 20 cheats, and the first part it should be able to use only one cheat, and for the second 20. So second part is definitely incorrect. Yeah, just accept, and let's add read input. Okay, so I will be stopping at this point Claude 3.5 Sonnet, because seems like it didn't solve it as well. Failed. So we've copied the Gemini solution. Okay, let's see if it solves at least the first one. Yeah, again, it takes time to calculate even the first one for some reason. We are not expected to wait so long for the answer. Okay, while we're waiting, we have an answer from O1 Pro. Let's change this model to experimental 1206. Delete and delete. Run again. So now, yeah, and we are going to do the same thing for GPT-4o, not GPT-4o mini. So let's select GPT-4o. Select here GPT-4o and normal. Okay, and let's see what we have here. Okay, so cheat marks length. Okay, that's fine. Solve part. Fit. Okay. Cheat marks length 2. Okay, I like this approach. BFS ignoring walls. BFS normal. Neighbors. Okay, let's go. So let's copy this to 01. Okay, Gemini, no points for you. Not for thinking model. Let's run for 01 once again. Okay, so we again have something to do with some. Okay, so we have an answer for the first part, and this is a correct answer. Okay, that's good. Let's see if it solves the second part, and it's definitely going to be slightly longer, because we are allowed to cheat many more times and many more parts. Okay, we have an answer. Hopefully it's a correct one. Yeah. Okay, O1 Pro solved it. That's really good. We have, okay. Oh, I like this. So, okay, O1 Pro solved it. We have an answer from the Gemini. Let's copy. Yeah, now it's 1206. Not thinking, not Flash 2.0 thinking, but 1206. So let's go again. Okay, it failed again with the path, no problem. Okay, let's go. There are a lot of ifs. I don't like the indentation in this code, because it doesn't even like fit in the screen. Okay, let's wait for some time. We have an answer from GPT-4o. Okay, cheat true. Why? You are allowed to cheat in the first part? Okay, so GPT-4o didn't understand the task. We accept it, and let's launch it. CD day 20 solutions, and let's see if at least solves the first one. GPT-4o. No, nothing. This is definitely a much trickier problem for the models. I like though that O1 Pro at least solved it. That's a good a good how do you call it? A good sign. Gemini is probably will probably fail it, so I won't be waiting for this long. So what do we have? Success for the O1. It's O1 Pro, but yeah. Okay. Should we stop now? Yeah, let's stop. I don't like the solution. I don't like that we are waiting for so long. Okay, so we have a results. We have results for the models. Solve. day 20. Cool. Now I will be using the same prompt except for the description of the task for the next stream for the day 21, which we are going to do in a minute. CD 2021 solutions. Yeah, 21 solutions. I haven't tested DeepSeek. I forgot about this. So let's go back. Let's create. Sorry, I forgot about it completely. I need to create a new window for this, so I won't be forgetting. Okay, so let's go back. Where are we? Say 20 solutions. Python DeepSeek. No. So yeah, nothing for DeepSeek here. Failed. Yeah, cool. Day 20 DeepSeek has failed. Okay. So if you are still watching, go to the Telegram channel that I have posted link in the comments, where I will be placing another link for the next stream that is going to be in 2 minutes. So yeah, just go for it.